even or odd or neither based on the equation. What we did is we actually find out whether f of x is equal to f of negative x. If it proves this equation, then that's even, or if it proves this equation f of negative x is equal to negative f of x, that's an odd function. If it doesn't satisfy both of them, it's neither. Now here what we are going to do is we are going to look at graphs and see how we can say whether a function even, odd or neither from a graph. Okay, now let's look at some function for the graphs. Okay, so how to actually determine whether a function is odd, even or neither from a graph. So if a function, let's say you have a graph that is symmetry around the y-axis, that's an even function. And if it's symmetry around the origin, that is that is an odd function. And if it's not satisfying both of them, that's neither. Now let's go ahead and see an example. Let's say we have f of x that's equal to x square, and we know that when we have x square, that is a parabola that's going to be opening up in the positive y-axis. So it's going to be like that, and this is even both sides. Like if you look at this one, like even though I'm not my drawing is not perfect, but it's going to be even in the left side of the y-axis and the right side of the y-axis. So it's even in the it's symmetry in the y-axis. Therefore this is an even function. Now let's look at another example. Let's say we have f of x is equal to x cubed. Okay, now the function of x cubed is going to go like this. It's coming from the negative infinity and goes to positive infinity. So it's going to go like this. Is it symmetry around the y-axis? Is the left side of the y-axis and the right side of the y-axis look the same? No, because if it's only upside, it's going to look the same. But here it's downside and it's going up in the positive y-axis. So it's not symmetry around y-axis, but it's symmetry around origin, because if you take this quadrant 1 and compare with quadrant 3, it's actually same. So that's why it's symmetry around origin. If it's symmetry around origin, it's an odd function. Now let's look at this one. F of x is equal to 3. You know, f of x is actually y is equal to 3. If y is equal to 3, it means we have 3 right here, and this is a straight line at 3. And you can see this is like symmetry around the y-axis, because if you cut this one into half, you will see in the negative x-axis and positive x-axis, you're going to have exact same values. So this is symmetry around y-axis. Therefore this is an even function. Now let's look at another example. Let's say we have y is equal to x. Is it even or odd? Y is equal to x is a straight line. It goes through the origin, and you can see from for this one, is it symmetry around the y-axis? No, because when it's negative y, the values are different. When it's positive y, the values are different. So it's not symmetry around the y-axis, but it's symmetry around the origin. If you look at quadrant 1 and quadrant 3, it's the same. So since it's symmetry around the origin, this is going to be an odd function. Okay, now let's look at another one. Let's say we have a graph like this. Is it even function or odd function? You can see this is not symmetry around the y-axis. This is symmetry around the x-axis but not y-axis. So we don't have any condition that it should be symmetry around x-axis. Like symmetry around x-axis doesn't mean nothing. Like it means nothing. So it has to be symmetry around y-axis or symmetry around origin. But here it's not symmetry around origin, because in order to be symmetry around origin, it has to be other side of this other side. But here this is not symmetry, so this is neither. Let's look at this function. Let's say we have a function opening downward. what is it even function, odd function, or neither? If you look at y-axis, it's symmetry around y-axis, so this is an even function. Now let's look at some more graphs. So let's say we are having a graph like this. Okay, it goes up and then goes through the origin, and then it goes like this. Okay, is this even function, odd function, or neither? Now, in order to be even function, it has to be symmetry in the y-axis, but this one is not symmetry in the y-axis. In order to be symmetry, this one has to be upside and look exactly the same, but it's not symmetry on the y-axis. But is it symmetry around the origin? That's yes, because if you look at quadrant 1, it's exactly same as quadrant 3, and if you look at quadrant 2, that's exactly same as quadrant 4. So this is symmetry around the origin, therefore this is odd function. Now let's look at another example. Let's say there's a graph like this, coming from infinity and going like this, then going like this, and then going to infinity again. Is it odd function, even function, or neither? Here you can see this is symmetry around the y-axis, therefore this is an even function. Now let's look at this one. Let's say we have a graph like this. It goes like this, but here it's little less like this, and then goes. Is it odd function, even function, or neither? So in order to be even function, it has to be symmetry around the y-axis. Is it symmetry around the y-axis? No, because the left side and right side doesn't look the same. Is it symmetry around the origin? In order to be symmetry around the origin, this if you look at quadrant 1, quadrant 2, quadrant 3, quadrant 4, wherever the graph goes through, it should look the same. Now let's compare this one. Quadrant 1 and quadrant 3 looks almost the same, we can say almost, but if you look at quadrant 2 and quadrant 4, the quadrant 4 is smaller than quadrant 2, so this is not symmetry around the origin. So this is neither. What about this one? Let's say we have a circle like this. Is it even function, odd function, or neither? Now for even function, what has to happen is it has to be symmetry around the y-axis. Is it symmetry around the y-axis? Yes, because if you look at this one, right side and left side exactly the same, so this is even. But if you look at odd function, like odd function is symmetry around the origin, again it's exactly the same around origin as well. So this is similar here, similar here, similar here, similar here. So this is satisfying both of the conditions. So is this even, or is this odd, or is it neither? Now the problem here is, if you pass a line test for this one, like if you watch my previous video, like if you draw a vertical line and if it goes through 2 points, like if it's more than 1 point, if it meets more than 1 point, that's not a function. So if you draw a vertical line for this one, it passes through multiple points. Here it's meeting here and meeting here, therefore this is not a function. So we cannot say this even function, odd function, so this is coming under neither. And if you watch my previous one of the example here, we should have said the same thing for this one. I wanted to make this one a surprise, so that's why I didn't say it right here. Here also you can see if you draw a vertical line, it meets more than 1 point. So you can, from that one also you can say this is neither, because this is not a function, therefore this cannot be an even function or odd function. So that's it for this video, guys. Thanks for watching. See you guys on my next video.